Hello, good day. My name is Razel Rodrigo, and today I'm going to do my data communication and networking for course project. For this activity, there are three groups. There are a list of topics and divided into three groups, and I have to choose only one group, which is the group three. And the topic is all about one concept, network evolution, part one, which is the Internet of Things, and part two, the network programming. And the last one is the network troubleshooting. And the one network, one concept, I mean, one concept, which is a wide area network, or one is a telecommunication network that extends over a large geographic area from the primary purpose of computer networking. Wide area networks are often established with leased communication circuits. Businesses as well as schools and government entities use wide area networks to relay data to staff, students, clients, buyers, and suppliers from various locations across the world. In essence, this mode of telecommunication allows a business to effectively carry out its daily function regardless of location. The internet may be considered a one or a wide area network. The second topic is about the network evolution, and the part one is Internet of Things. Internet of Things is all about data. So Internet of Things is a or IoT is a computing concept that describes the idea of everyday physical object being connected to the internet and being able to identify themselves to other devices. This would mean that normal everyday households items will be integrated with sophisticated tech to do more. You might also know IoT or Internet of Things as smart. At the moment, it is currently in the infancy stage with some devices around like smart TVs, smart refrigerators, and smart entry locks. Sooner or later, things like driverless cars and personal assistant devices, example Google Glass, would become a norm. These devices work by using sensors that transmit data to a computer or software, allowing them to perform important tasks. Due to their utility and high levels of automation, there has been an increase in the number of devices being connected to the internet. Um, there are five benefits of the Internet of Things. Internet of Things it is an important piece of technology that is set to improve greatly over time. There are many advantages of having things connected to each other. Here are a few of the benefits. The first one is more data means better decisions. With added sensors, these devices are able to collect a large amount of data on many different areas. For example, in addition to the practical elements of being able to know which food are going out of date in your smart refrigerator, this enhanced household item will be able to give you additional information on its power consumption, temperature, average time of the door spent open and much more. A greater flow of information means that company behind the device can analyze large trends in the data to better improve the feature of the device. Many companies are realizing the power of this technology and it is leading to a large increase in the market. In fact, the total market value of IoT or Internet of Things is set to grow to over $3 trillion annually by 2026. The second benefit of Internet of Things is the ability to track and monitor things. As well as tracking data for a company to use, it is also greatly benefits the user. These devices would have the ability to keep an eye out on the current quality of goods at home. Knowing the state of your items will allow a homeowner to know when they need to replace an item without without them without them having to consistently check the quality themselves. The third benefit of Internet of Things, which is is all about lighten the workload with automation. Having a device doing most the work for you means that you can save more time and cost. Imagine having your fridge or order a new carton of milk to be delivered when it reaches a certain level of expiry. This greatly reduces human efforts. It also results in devices being created that need little to no human intervention, allowing them to operate entirely on their own. The fourth one is increased efficiency by saving money and resources. As well as saving time for the device owner, it can also result in cost savings. For example, if lights automatically turn themselves off the moment you leave the room, you could save a lot of money on your electricity bills. As, as you can see, connected devices can provide many useful implementation. The IoT or Internet of Things system encourages machine-to-machine or M2M communication, resulting in increased long-term efficiency for both the company and user. The rate of growth for machine-to-machine communication is high. The total number of connections are set to grow from 5 billion in 2014 to 27 billion in 2024. The last one is about better quality of life. In the end, all the benefits lead to an increased quality of life. Having your devices track and order things for you, turn light switches off for you, and help manage important tasks that you may not have the time to do yourself certainly takes away a lot of stress. There is no doubting that people are generally getting busier as years go by. With so many devices being created and new technology being implemented, it's hard to keep track of everything. It's great to be able to do the things you enjoy and have a computer take care of the mundane things you know need to be done. Improvements to your lifestyle, health benefits, and improved wellness are also part of the Internet of Things future. For example, those that exercise regularly can utilize wearable technology to help them track their heart rate, body temperature, hydration to stay in shape, and monitor their health. That's all for Internet of Things. So the part two is about network programming. Network programmability is a set of tools to deploy, manage and troubleshoot a network device. A programmability enabled network is driven by intelligent software that can deal with a single node or a group of nodes or address the network a single unified element. The tool chain uses application programming interfaces or APIs which serve as the interface to the number or controller. The tool chain also utilizes software that uses the API to gather data or intelligently build configurations. The term network programmability can have different meanings depending on perspective. To a network engineer, programmability means interacting with a device or group of devices, driving configuration, troubleshooting, or etc., with a software that sits above the device. To a developer, network programmability means abstracting the network such that it appears as a single device that can be manipulated with specialized software or within existing software. Both perspectives are correct and drive toward the same goals of using the network to enhance and secure application delivery. And then the software defined networking, or SDN, enables the programming of network behavior. I'm sorry, this is behavior in a centrally controlled manner through software applications using open APIs by opening up traditionally closed network platforms and implementing a common software defined networking control layer. Operators can manage the entire network and its devices consistently, regardless of the complexity of the underlying network technology. There are four critical areas in which SDN technology can make a difference for an organization. The first one is the network programmability, or SDN enables network behavior, which is the same as this one. This one. Okay. The second one is the logically centralized intelligence and control. Um, okay. Software-defined networking is built on logically centralized network topologies, which enables intelligent control and management of network resources. Traditional network control methods are distributed. Devices function autonomously with a limited awareness of the state of the network. With the kind of centralized control an SDN-based network provides, bandwidth management, restoration, security, and policies can be highly intelligent and optimized, and an organization gains a holistic view of the network. The third one is abstraction of the network. Services and applications running on SDN technology are abstracted from the underlying technologies and hardware that provide physical connectivity from the network control. Applications will interact with the network through APIs instead of management interfaces tightly coupled to the hardware. The fourth one is the openness. SDN as architectures ushers in a new era of openness, enabling multi-vendor interoperability as well as fostering a vendor-neutral ecosystem. Openness comes from the SDN approach itself. The open APIs support a wide range of applications, including cloud orchestration or OSS or BSS, and business critical network app. In addition, intelligent software can control hardware from the multiple vendors with open programmatic interfaces like OpenFlow. Finally, from within the SDN, intelligent network devices and applications can run within a common software environment. A key advantage of SDN technology is the ability for operation network operation I'm sorry operators to write programs that utilize SDN APIs and give application control over network behavior. SDN allow users to develop network-aware application, intelligently monitor network conditions, and automatically adapt the network configuration as needed. Software-defined networking controller. A controller or SDN controller centralizes the control of the network devices. The degree of control and the type of control varies widely. For instance, the controller can perform all control plane functions, replacing the device's distributed control plane. Alternatively, the controller can simply be aware of the ongoing work of the distributed data, control, and management planes on the devices without changing how those operate. And the list goes on with many variations. To better understand the idea of a controller, consider one specific case as shown in figure below, in which the SDN controller centralizes all important control plane functions. First, the controller sits anywhere in the network that has IP reachability to the devices in the network. Each of the network devices still has a data plane. However, note that none of the device has a control plane. In the variation of SDN as shown in the figure, the controller directly programs the data plane entries into each device's tables. The networking devices do not populate their forwarding tables with traditional distributed control plane process. Note that shows the model used by one of the original SDN implementation that uses an industry standards called OpenFlow. This is the figure. Shows one model of for network programmability and SDN, but not all. The figure does give us a great backdrop to discuss a few more important basic concepts, in particular the idea of the southbound interface, or SBI, and a northbound interface, or NBI. That's all for the network programming. And the last topic is about the network troubleshooting. Network troubleshooting is the combined measures and processes used to identify, diagnose, and solve problems within a computer network. It's a logical process that network engineers use to resolve network problems and improve network operations. Troubleshooting is an interactive process. The more data you collect and analyze, the higher the likelihood of developing a correct hypothesis. There is a standard troubleshooting formula. Okay, so having a systematic approach to solve the problem will make you a faster and smarter troubleshooter. And in every network nightmare scenario, the faster the better. The formula at face value is a simple one. Define, isolate, and solve. Once you have checked the basic line, making sure it is not a physical layer problem, or it is a plugged in, and that the involved devices respond to ping requests, the real troubleshooting starts. Most troubleshooting involves a roll in and roll out process to help narrow down the location and cause of the problem. Here are some tips of troubleshooting. First is collect information. Second, develop a hypothesis. Third, test the hypothesis. And the fourth is implement a fix. And fifth, verify the problem was solved. Sixth, notify the users. And the seventh, the last one, is document the fix. What type of information should be collected? Okay, when collecting information on the problem, it is critical to make sure that you know enough about the scope of what part of the network is included in the problem and what part of the network can be safely excluded. Otherwise, you might be stuck forever trying to collect and analyze information that might be unrelated to the problem. Start by asking yourself the necessary questions to define the scope of the problem. First is, who is having the problem? One user or multiple users? Is it just one application or all applications? Has anything changed? Has this happened before, or if so, when? Can we reproduce the problem? Was anything done differently? So once the issue is defined, try to isolate it. This involves a process of elimination. If a workstation is having connection difficulties, determine if the problem is isolated to the specific workstations, all workstation in that physical location, or if it's network-wide. If it's local, you've eliminated a ton of unnecessary work and you're much closer to isolating the issue. Even if you haven't yet solved the problem, you have now saved valuable time. That's all for this activity, and thank you.